Welcome back. We're going to learn some more about Laplace transforms today with translation and then some more partial fraction decompositions with repeated factors. And to bring today up to speed here just a little bit, one thing that I want to do is remind ourselves of integration by parts. So if I had the integral from a to b of u times dv, that is uv minus the integral of v du, and we evaluate using our original limits. Okay, so we're going to learn about the translation here and on the Laplace transform. Excuse me. And remembering that our Laplace transform is this integral e to the negative st times f of t dt, and it works for all s values for which the integral converges. Now, s is a constant, even though he's a letter, he stands for a constant. So let's go ahead and use the definition to find the Laplace transform on t times e to the 3t. And I'll even write out the first step for you here. So that's going to be the integral from 0 to infinity of e to the negative st times t times e to the 3t dt, which I'm going to rewrite as the integral from 0 to infinity of t times e to the 3 minus s t dt. So we're going to need two techniques here from Calculus 2. The first being the integration by parts, and the second being the improper integrals. So this is going to work out to be the limit as b approaches infinity of the integral from 0 to b of t times e to the 3 minus s t dt. So let's set up our integration by parts. Let's let u be t, and then therefore du would be dt, and then that means dv equals e to the 3 minus s t dt, and his antiderivative, realizing that 3 minus s is simply a constant, is just going to be 1 over 3 minus s times e to the 3 minus s to the tth power. Okay, so with those substitutions, we can do our integration by parts. So we'll get still the limit as b approaches infinity of our integration by parts. So I'll need uv, so t times 1 over 3 minus s times e to the 3 minus s t, and we evaluate that from 0 to b, and then we need to minus the integral from 0 to b of v du. And so that's the purpose of integration by parts, is whittling down a nasty integral into something that's a little bit more manageable. All right, so let's go ahead and do our two parts here. Let's do the first part. Let's see what happens as we evaluate here. Well, when we put in t equals 0, we're going to get 0 because that's going to be times by 0. And notice that s can't be 3, otherwise we get to divide by 0, which destroys the universe. We don't like that. So we're going to put on the restriction that s is greater than 3. And so if s is greater than 3, 3 minus s is a negative number, and e to a negative large power, because we're going to let t go, we're going to substitute the b in for the t, and as b goes to infinity, this is going to be e to a negative super large power, which will then give me 0. So we'll get 0 minus 0 for the first part here. So it really works out to just what's going to happen here with this second part. And we've, let me go ahead and do this, minus 1 over 3 minus s integral 0 to b of e to the 3 minus s t dt. Oh, and I got to be careful. I'm still doing the limit as b approaches infinity. I'll weasel that in there really tiny, but he's there. So when we do this guy here, oh wait, we've already handled this integral when we were doing our integration by parts. So we're going to get negative, oh, let me write my limit here. So we'll do limit as b approaches infinity of negative 1 over 3 minus s times the antiderivative of this, which is 1 over 3 minus s e to the 3 minus s times t. And we're going to evaluate that from 0 to b, and then let the limit as b goes to infinity. So s is a constant, so 3 minus s is still a constant. So I'm going to write this as the limit as b approaches infinity of negative 1 over 3 minus s squared times e to the 3 minus s times b minus e to the 3 minus s times 0, which is 0. Okay. And as we mentioned before, provided that s is greater than 3, this is a negative number, and e to a negative large number goes to 0. And e to the 0 is 1. And so we're going to get the negative 1 times the negative 1 would be 1 over 3 minus s squared. But sometimes we like to put this in a slightly different form using just some algebra. What if I were to times the bottom by 1, namely negative 1 squared? That would give me 1 over 3 minus s times a negative 1 all squared, which would give me 1 over s minus 3 squared, which is the form you're more likely to see him in. Whew, now that took a few minutes, but let's compare and notice what happened here. So this was the Laplace transform of t times e to the 3t. Remembering that the Laplace transform of t to the first power is 1 over s squared, how does the Laplace transform of t times e to the 3t compare? We'll notice that it is very, very similar in that if I cover up this minus 3, it looks the same. And that 3 happened to be the coefficient of the t in the exponential here. Oh, so we notice that this is 1 over s minus 3 squared. And so we saw that it's basically of this form, 1 over something squared, but we do a translation here because of the times by e to the 3t. And we see that translation occurring in our definition here. So what's the big ta-da that I want you to get out of this part of the video? Well, the Laplace transform of t times e to the at, where a is any constant, will be 1 over s minus a squared. Okay. So we just do this guy right here, his Laplace transform, and then this just does a translation or shift. Okay, let's stop there and pick up in the next video.